Alright, hey everyone. Another coding challenge tutorial thing for you. Um, what we're doing here is we're making this particle system that kind of looks like circuit board kind of stuff. I don't exactly know how you'd describe it, but yeah, looks pretty cool, so let's get started. So we've got blank processing sketch. So first thing we're going to do, of course, set the size of the window, so 1080 by 720. So we're going to create these little circuitry looking particles, hopefully. So first thing we're going to do is create a new, if I can click the thing, new class, call it a particle, like this. So class particle. Particle's such an annoying word to type. Anyway, class particle and particle like this. It's so long. So what we need for it to work, we need an x and a y, obviously. Float x, float y, can't spell float y. Oof. It's going to need a direction, so like an angle. Float angle, it's going to need, I think, is that about it? Oh, a color. Int c for color, like that, and then we're going to have to create all of these variables up here, so float x and y and angle, and then int c like this, and then we just go this dot x equals x, this dot y equals y, this dot angle equals angle, and this dot c equals c. Alright, all annoying stuff out of the way. So we're going to do an update function and a show function. So void update, don't know why I did that, void update, and then void show. If you're at all curious why I always separate the update and the show function, it just makes it easy if you want to do like a pause screen or something like that. You can keep running the show function each frame, but not run the update function, so nothing will move, but you're still displaying it on the screen. It just makes it easier for that. So if you're curious as to why I always separate them out, that's why. And I guess it's also just pretty good practice. I don't know. I'm not a professional yet. So in the update function, what we're going to do is we're going to move the particles. So what we're going to do is we're going to say float x plus equals cos of the angle times, we need a speed. I guess we probably don't need to pass that in because we probably want it to be constant for all of the particles. So we'll go float speed equals 5 for the moment. I don't know. And then we're going to copy this and we're going to paste it in. And we'll say, oh, right. I was wondering why this was giving me an error. Don't need the float bit there. So x plus equals cos of the angle, y plus equals sine of the angle times the speed. So that means that it'll shoot off in that angle at that speed. Cool. So if we ran this now, we wouldn't get anything because we don't have anything in the show function. So what we're going to do is we're going to say fill. We're going to use HSB color mode, which stands for hue, saturation, brightness, and that just makes using random colors look nicer because you won't get any like grays and browns and all that sort of stuff. You'll just get nice rainbow colors. So we're going to use the C value for the hue. The brightness and saturation will be full 255 because that way we get nice colorful rainbow colors. And then we're literally just going to draw an ellipse at x and y, and we'll make a variable for the size of the thing, so we'll make them 5 as well, I guess. So then we go sus and sus like that. So now we should be able to say particle p equals new particle at width on 2, height on 2, what else does it need? An angle. I guess we can just give it 0 for the moment. 0 and a color. So we'll say int random 255. So just a random integer between 0 and 255. So if we run this, we can say p dot show like that, and we should just get a colored dot in the middle of the screen. So there's a little blue dot in the middle of the screen. So firstly, there was an outline around it, so I'm going to say no stroke. Also, I'm going to say I'll move this to move this to the draw function so that I can also say p.update, and then I'll need to move this up to here like that so that it's global. And now I should get, it'll be a little dot in the middle of the screen that should move to the right. Yeah, so it's moving that way. Cool. So what we want to do now is we want to make sure that when it's off the screen, it stops updating. And actually this will come into effect more when we're using an array list of particles, because when it gets off the screen, we'll just remove it from the array list so it won't get updated anymore. But we'll implement it now because it'll be handy for performance reasons later on. So boolean dead equals false. So it's going to start off as an alive particle, and then we're going to say, after we've updated all the positions, we're going to say if x is less than 0, or x is greater than width, or y is less than 0, or y is greater than height. So essentially, if it's off the screen in any direction, it will become dead. So dead will equal true. So that won't do anything at the moment. It'll still just go off the side of the screen and whatever. What we want to do now is we want to make it so at the moment it just travels at a constant angle. So what we want to do is we want to make it, instead of going at a constant angle, we want it to change direction occasionally. And to make it look kind of circuit boardy and like electrical, I don't know, we'll make it stick to like a multiple of 45 degrees, because traces on PCBs always stick to multiples of 45 degrees. So to do this, what we're going to say is we're going to say if random1 is greater than 0.95, just a random, so there's a 5% chance that this bit of code will run each frame. So if we're going to change direction, so this is the chance that it will change direction. If we are going to change direction, we need another random thing to say if it's going to like rotate left or rotate right. So we're going to say if random1 is greater than 0.5, so this is a 50% chance, then what we're going to do is we're going to say angle plus equals pi on 4. So pi on 4 in radians is 45 degrees. So if it's greater than 0.5, we'll move it one way, and if it's less than 0.5, we'll change that plus to a minus, so it goes the other way. So now if we run this, we should see that, yeah, the particle changes direction, and it takes a while to leave the screen. So you can't really see very well what's going on when there's only one particle. So we're going to create an array list of particles, which means that we can really easily add more particles to be moved around and whatever. So we're going to turn this p variable from just one particle to be an array list of particles. I'm going to say new array list particle like that. So that's a new list. I think I spelt it wrong. Part equal, not part sul. And then this won't work anymore, but what we're going to say is we're going to say for int I equals 0, I is less than p dot size I plus plus. Oh, actually, we're going to want to do this backwards because we're eventually going to be removing particles from the screen. And so if you go forwards through the array, but you're removing particles, everything will shift down, so you'll skip particles when you're trying to update them. So to do this, it's not very tricky. Instead of starting I at 0 and working up towards size, you start I equal to p dot size minus 1, and then we want it to go until I is, we want it to keep going while I is greater than or equal to 0, and then instead of I plus plus, we say I minus minus, like that, and then we put these in the loop, like that. And then instead of just p dot update, it's got to be p dot get. Oh, I hit caps lock. Get I dot update and p dot get I dot show. Okay, so now we've got an empty array list, but to add things to it, oh, I forgot the that. So to add things to it, we're going to create a function, and I'm going to call it burst, because it's like a particle burst. So burst like this. Ooh, and then as a parameter, the number of particles in the burst. So then we're just going to say for int I equals 0, I is less than num I plus plus. And then, so I kept that bit of code from way back up the top. So we're going to say p dot add a new particle like this, and so it's always going to be in the middle of the screen, and it's always going to have an angle of 0. So to change that, we're going to say float a equals an int that's random between 0 and 8. So because we're wanting to keep it on multiples of 45 degrees, there are 8 segments of 45 degrees that make up a full rotation. So we're going to get a random variable between 0 and 8, and we're going to times it by 45 degrees, pi on 4 radians. And then we're going to put a in here. And then instead of a random color, at the moment, if we run this, if I type in burst up here, they'll all be, all of the colors, oh right, need a number. All of the particles will be a different color. So if I run this, you'll see, hang on. Why are they all, they're all like blue and white. Did I put the, oh, it's because we're still using RGB color. I forgot to switch that over. So we'll say color mode, HSB. So now we should see that we get rainbow colors. So if we run that, they're all different colors. So what we want to do is for each burst, we want this to be the same color. Yeah. So in the same burst, we want them all to be the same, like that. So that should mean that now they're all the same color. Yeah. Cool. And so if we run it again, hopefully it's the exact same color. Run it again. Oh. Always the same. Oh, there, okay. We must have just been getting extremely lucky with that one. So, one thing we can do is, it might be cool, instead of just seeing one particle for each, instead of just seeing a particle as a circle, it would be kind of cool to see like a trail of where they've been. So, one way we could try and do this is we can say, instead of clear, we can say that the background should be black, but then have a slight opacity to it. So, for instance, like 100. Okay, so that doesn't work. Another way we could do it, if that doesn't work, which it doesn't, is we could store the old positions of the particles and display them to the screen. So to do that, I might say array list p vectors. So an array list of p vectors equals new array list p vector, like that. Okay, so we didn't give it a name. We're going to call it old because it's storing the old positions. And then in the update, before we actually change the x and y, we're going to say old.add new p vector, and its x and y are going to be the current position. And then what we're going to do is in the show function, we're also going to show the trail. So we're going to say for int I equals 0, I is less than old dot size I plus plus. And then we're going to say ellipse at old.get I.x and old.get I.y, and then the size is going to be the same, like that. So now if we run this, we should see that we get a trail. Whoa. And it gets really slow because we're storing. So the reason that was happening is because we're actually storing all of the old positions, whereas we probably only want to store like the previous, I don't know, like 10 or 20. So the way we can do that is in here we can say while old.size is greater than, here I'll make a variable for it, and we're going to say int tail length equals 15 for the moment. So while it's greater than tail length, we're going to say old.remove old.size -1. So it's going to shorten and shorten. Another thing that we need to do is when we're adding the old position, the newest old one, we want to add it at position 0 so that it's always at the top of the array list because we're removing them from the bottom. I guess we could do it actually more simply the other way, is by always removing the first element and just adding. That makes a lot more sense. So now if we run this, we should see that they're not getting infinitely long. So that's good. But as you can see, they're still coming back onto the screen if they go off it. So remember how before we made that dead boolean so that if they're off the screen, they become dead. What we're going to do is in the for loop while we're updating them, we're going to say if p.get I.dead, so if it is off the screen, we're going to say p.remove I, and then continue, because what that does is it just goes to the next number in the for loop so that we don't get errors trying to show the next one, because when you remove from the array they all get shifted down. So that'll just stop some errors happening. So now if we run it, when they go off the screen, okay, so what you can see is that they get removed as soon as the first point goes off the screen, but we probably want it to be removed when the last point goes off the screen. So to do that, instead of just x and y here, we're going to say old.get old.size -1.x. Actually, you know what, it might be better to say p vector old oh no, we've already got something called old temp equals. So that's the last one. Oh, the last one is, hang on. The last one is at the start of the array. Okay, so we don't actually need that. We can just say 0. Okay, so that'll probably be fine then, not making a temp variable, because otherwise it just gets like really long on the screen. This is nice and short though. So now if we run it, it should be when the end of the tail gets off the screen that it gets removed rather than the start of it, which makes it look a lot better. So now they're all disappeared. So that's good. But as you can see, there's only one burst. So what we can do is we can say if, not if, void key pressed, and then we can say if key equals the spacebar, then we can do a burst, and we'll say 100 again. So now if we run this, every time I hit the spacebar we get a new burst. Looks pretty cool. One thing I think would look really cool is in the tail, if they got more and more clear, like less and less opacity as you get towards the older ones. So the oldest one is at 0, so we want to say fill C 255 255, and then the opacity is map I, that's between 0 and old dot size -1, and we want to say when it's the oldest it's 0, and then when it's the newest at the end we want it to be 255. Oh, semicolon. So if we run this now, they should sort of like fade out as they get older. Yeah, woo, look at that, that looks cool. Oh yeah, I like that. Okay, so I think we're pretty much done. So one thing that you can do is you can see when we do this, you can sort of see the dots in between each, because each particle is just a series of dots, but the more spread out they are, the more obvious those dots will be. So if this is something that you can play around with if you want to download the code, link in the description by the way. So if the speed was slower, you'd see that they all sort of clump up. Actually, hang on, instead of making them slower, I'll make the size bigger. So they'll all become sort of like a line rather than a series of dots. So this is something, as I said, you can play around with. So you can make it either a line, or you could make it like really obviously dots. By increasing the speed will spread them out more, but when you do that, oh, hang on, something is going wrong here. Okay, so it's saying I can't map 0. Oh, so if there are no elements in that array, it I think it doesn't like it very much, because I'm mapping 0 between 0 and 0. But I guess we can just say if old dot size is greater than 0, like that. So that should fix that. I'm not sure how long that error has been there. I assume since I wrote the fading in stuff. So if you've been shouting at your screen, noted, fixed. Okay, so now if we run this, oh no, still get the error. Anyway, I can sort that out in a sec. As you can notice, the dots are more pronounced when it's speedier, but they kind of zoom off the screen faster. So one trick for that is in this setup, you can set the frame rate of, what am I doing? Set the frame rate of your sketch so that if it's slower, they'll still be spread out, but they'll move at a slower rate. That's way too slow. But yeah, so that's something you can play around with. I liked it the way it was before, with just the normal frame rate and this at 5. I think it looked pretty cool. But yeah, something you can play around with. I'm not sure what's going on with this thing. I don't know how to fix that. Oh, so this will happen even if there's just one. So we might just wait for it to have two things in it. Yeah, okay. Um, Weird. Anyway, so yeah, this is like, I think this is done. I think we're done. That looks pretty cool, right? I guess there are a few more things you could do with it, like, because some of them are turning all the way around, but you could make it so that, um, I don't know, they can only go between a certain range of angles. But I think it looks really cool. And oh, another thing we can do is we can increase the tail size, which I completely forgot about. So we could set this to like 50, which will probably run really slowly, but it'll probably look really cool. Yeah, nice. All right, so thanks for watching this coding tutorial challenge thing. I don't really know exactly what they are, but yeah, hope you enjoyed it. If you want to check out this code, there'll be a link to the GitHub in the description. There'll also be a link for downloading processing, which means that you can actually do something with the code that's on GitHub. Um, so yeah, check them out. Also, there's a link to my website, which you can submit ideas for coding challenges and also vote on other people's ideas that they've submitted. So yeah, thanks for watching. If you want to, you could subscribe or something. I don't know. Up to you. See ya.